everybody. Happy Tuesday. The sun is shining. It's going to be a glorious day. I am excited for the extended sunny weather. My name is Kobe Flat, and you are listening to our Wassa radio station, where for the next hour I'm going to interrupt our music to present the MAP4C. That is our grade 12 college Foundations for College Mathematics course. We are on week 4 of our 9-week radio Zoom schedule. Every Monday to Thursday from 10 until about 11, we go through the MAP4C curriculum material. In the last 3 weeks, we have completed lessons 1 to 7. We finished lesson 7 yesterday, which was a 3-part lesson. It was quite extensive in looking at all of the different functions, our models, mathematical models. We are now jumping into switching gears and looking at lesson 8, which covers scatter plots. We are going to be exploring scatter plots and how to use them. We will better understand correlation through reading data. Our learning goals for today's class are that we will be able to create and use scatter plots. We will be able to explain correlation and identify whether it is positive or negative, or there being no correlation at all. Some of the keywords that you'll want to know for today's lesson are really about variables. The term variable simply means a letter or symbol used to represent a quantity that can vary. So this is a word that I've already used throughout this class as we've been doing our formulas, talking about how we need to substitute into our formula the variable x or a or b or whatever the letter is. Specifically looking ahead to our lesson regarding scatter plots, we're really looking at the relationship, the correlation between. So when we talk about one variable data, we're looking at a set of data that describes one attribute per item in a sample. If you hear two variable data, it's referring to a set of data that gives measures of two attributes for each item in a sample. Some more concepts that we're going to get into today you might be familiar with, and those are the terms mean, median, and mode. They might sound very familiar, but you might not have used them for a while, and you get mixed up. Which one is mean? Which one is median? Which one is mode? How do I calculate them? What is the one that I'm looking for? So to help refresh your memory, mean is talking about one measure of the average of a set of numbers, which is when we're looking at really a set of numbers, when you're looking at a lot of information and you want to find the average. It's one way to find. Now, to find the mean specifically, you divide the sum of the data by the number of that data. So what does that mean? That means if we have 4 numbers, if we have 12, 9, 10, and 3, what we'll be doing is adding them up because it wants you to divide the sum. So the sum means we add and we find out what it equals. So if we have 12 plus 9 plus 10 plus 3, we're looking at, if my math is right, 34. And you're dividing the sum, so the sum is 34, dividing the data by the number of the data. So here we have 1 for our number 12. 2 numbers gives us is 9, 10 gives us 3 numbers, and 3 gives us 4 numbers. So we divide by 4. So to find the mean, you're taking the sum of the data set, the set of numbers that you have, and you're dividing it by how many pieces of information, how many data sets there are. So you find the sum and you divide it by the number. So for our first example, the mean is we have 12, 9, 10, and 3. We're going to add them up. We get 34, and we divide it by 4. Now the median is the middle number of a set of data arranged in numerical order. Now if there are 2 middle numbers, the median is their average. So what we would do is we would take our example here where we have 12, 9, 10, and 3, and you have to arrange them in numerical order. So we would start with 3, then 9, then 10, then 12, and you would simply find the middle number. If there are 2 middle numbers, which we do here in our example, because we have 4 numbers, there is no middle number. So we would take both the 9 and the 10 if there are 2 middle numbers, and the median is their average. So the average between 9 and 10. If we wanted to solve this one, what we would do is say our median is 9.5. We sort of split that difference. We find the average. So our mean for our set of numbers is, if we actually do 34 divided by 4, we get, I'm going to put this in a different color, we get 8.5. Our median is 9.5. And then the mode is the most frequently occurring value in a set of data. So if we had, I am going to have to tweak this one a little bit. If we had 12, 9, 10, 3, 9, for instance, the mode would be the most frequently occurring. So we only have 1, 3, 1, 10, 1, 12, but we have 2 9s. So our mode would be 9 because it appears the most. Obviously that's going to change our other ones because I didn't include that second 9. But just as an example, when we're talking mean, you find the sum of all of the numbers and you divide it by how many numbers there are. The median is simply that middle number, and the mode is the one that appears most often, the one that has the most numbers. So there's a refresher on mean, median, and mode. Jumping into today's lesson, we are going to need to be able to understand data and what that looks like. It's important to note that data can be presented in a variety of ways. You can present data graphically. Graphical representations can include a bar graph, a histogram, a circle graph, and, drum roll please, scatter plots, which is what we're looking at today. To refresh your memory, a bar graph is a graph that displays data using horizontal or vertical bars whose lengths are proportional to the numbers they represent. So here I have on the board in front of me, if you're following along with our Zoom slides, I have a bar graph that looks at the tuition at an Ontario community college. On our y-axis, if you remember from our previous class, our y-axis is the one that runs vertically up and down. We have tuition represented in dollars. On our x-axis, that's the one that runs horizontal, we have the programs. So Our tuition ranges from $0 is our x-axis, that's the lowest point, and then it goes up by increments of 4,000, 4,000, 8,000, it would go up to 12,000. The programs that we have listed along our x-axis are the television and film, theater production, child and youth worker, web design, and photography. Now the data that's presented, we have bars that run vertically, they're going up our y-axis. We have red bars and we have blue bars. Now the first question in our practice question says use the bar graph to answer the following. What do the red bars in this graph represent? So we have, like I said, the blue and the red bars running vertically. And at the top, you'll see kind of this legend or this answer key. A lot of times when you're making a map, you have a legend and it tells you what the symbols represent. Whenever you have a bar graph, you have to have this legend or this key as well. There's a little red square at the top that says 2007 to 2008. That's telling us that all of the red bars, the information in the red bars, are portraying the cost of tuition for the various programs in the year 2007-2008. So the question says, what do the red bars in this graph represent? The red bars represent cost of tuition for various programs in 2007-2008. Then it says, what about the blue bars? So what do the blue bars in this graph represent? Well, we look at that legend or that key, and it has a little blue square, and then it says for blue, blue is representing the years 2008 to 2009. So the red bars are telling us the cost of tuition for various programs in 2007-2008. The blue represents cost of tuition for various programs in 2008 to 2009. So knowing that, we're going to answer part B, which says for which program did the tuition change the most? So we look here at our bar graph, and what we're looking for is the difference in height, because the height tells us the tuition cost in dollars. And so we want to find where's the largest height difference. If you're following along on Google, our Zoom slides, you will see that television and film has quite a significant height difference. The program of theater and production, they're really close. There's not much difference between them. Same with child and youth worker. They're really close in height, not much difference between them. We do have a more significant gap in tuition for web design and not much at all for photography. So really what it comes down to is web design and television and film. And what you would want to do is you can sort of make this line go across to our tuition to find, okay, that tuition is probably about almost 7,000, maybe $68,000. And then we take the line from the tuition in 2008, 2009, and there's maybe $200 difference. Then we look at our television and film program. In 2007, it was at $10,000. And then if we look at 2008, 2009, it's probably about 11,000. So there's a greater gap, a greater difference in the height between the bars in television and film program, which means that the tuition changed the most. There was a greater difference in the program television and film had the largest change in tuition? Then the last part of this question says estimate the tuition for photography in 2007-2008, so that's the red bar graph, and in 2008-2009, so that is the blue bar graph. So same thing, you're going to take your line and you're going to bring it across to your y-axis so you can see where it falls on that scale. And you can see it's just below our solid line, which would be the $6,000 mark. So we can estimate that the tuition for 2007-2008 is approximately $5,900. The tuition for photography in 2008-2009, now if we bring the height of that bar across, we can see it's just above our 6,000 mark. So we can estimate that the tuition from 2008 to 2009 is about $6,100. You can use bar graphs to represent the data collected and put it in a nice way for your audience, your readers, to view, where they don't have to sit and flip through pages of research. A bar graph can also be done, we said vertical or horizontal, so you could have the programs on the y-axis and the tuition on your x-axis, and you could have the blue bars and the red bars, and it would show essentially the same thing. So you can see how much the tuition is. It's up to you how to present your information, and we're going to get into that in the next few lessons. How you choose to present your data can make a huge difference on the impact of the viewer or the audience. Now, a histogram is another way to show your data. A histogram is a diagram that uses rectangles to demonstrate through their area the frequency of a variable, and through their width the continuous range of numerical values. So if we look at our practice question here, you can see it looks a lot like a bar graph, except this time the width also counts, not just the height, but the width as well. Our question says the histogram shows the training heart rates in beats per minute of 16 runners. Part A says how many runners had heart rates between 140 to 149 beats per minute. So on our y-axis, we have the number of runners. On the x-axis, we have our beats per minute. We want to find how many runners had heart rates between 140 to 149. So we need to look at our x-axis. If you're following along on Zoom, you can see that our graph has this little break in the line on our x-axis to start with. And that's just to represent the jump that we're doing so that we can get a better visual. They could have made their x-axis. They could have counted by tens the whole way, but your graph then would have looked, if you're following along, your graph would have had this huge gap until we got to 120, and then all of your information would have been sort of at the end of your graph, and it would have looked a little bit off. So in order to shorten that gap of information, you do a break in the line, and that allows you to take out this section and just start your graph where your visual, however you're representing it, whether it's like a histogram or a bargram, allows it to be more centered. So that's what that line means, that break. So we recognize there is a break. We recognize there's a whole bunch of information or different heart rates, different beats per minute, but we're just looking at, we want to focus on the information that we were presented with, which shows us the lowest runner had a heart rate of 120 and the highest a heart rate of 180 beats per minute. So we're looking specifically at the 140 to 149 bar. That's the one we want to look at. Now that we have found our range of 140 to 149 beats per minute, then we can go up and see how many runners were in that range. So we follow to our y-axis, and we can see that there were 3 runners. So for part A, we would say 3 runners had their heart rates between 140 to 149 beats per minute. Remember, you always want to use complete sentences. It's a good habit to get into. If this question's just worth 1 mark, you can just say 3 runners. That is okay. But to get into the habit of writing word answers for our word problems, it's a good system to get into, a good habit to get into, so that when we have our larger word problems and we do our therefore statements, we'll be pros. The next part of this question says, what interval was the most common? So what it's asking is, we want to see the largest number of runners and then find which interval they were at. So what interval was the most common? So here, if we look, we were looking for our tallest bar, which is 4. So 4 runners, that was our most. So that's the most common. Then we want to find out, well, what's the interval? So we're looking at what that bar represents, and it has the heart rate between 160 to 169 beats per minute. So we can say the most common interval, well, that's fun. All of my slides just changed. Hokey doodles, it skipped a lot. Here we are. The most common interval was 160 to 160 beats per minute. You could also say 4 runners had heart rates between 160 to 160 beats per minute. There are different ways to write it, as long as you are showing that you can read the graph and see that we're looking at the most common, so the highest number of runners, and then looking down to the x-axis, which has the interval. We're just practicing reading graphs for information. The last section says, what were the minimum and maximum heart rates any of these runners could have had? We talked about that break in our x-axis at the bottom, And the lowest you can see is 120. If there was anyone lower, they probably wouldn't have had that break, or they would have started it at 110 and had a bar there. But because the first piece of information starts here at 120 beats per minute, we know that the minimum is 120 beats per minute. And then we do the same. We go to the maximum, so to the far end of our x-axis, and we can see the last piece of information recorded, the last data that was given is maximum 180 beats per minute. If it was any higher, we would have seen on our x-axis it moving further to the right, and our information would have been higher or presented at 190, for instance. The other thing that we can say is, because our information has been between, so 100 to 129, and then it's 130 to 139, 140 to 149, it is safe to say that our maximum is 179 beats per minute. There's nothing over, so you can have it as 179 beats per minute. Our next example that we're going to look at is a circle graph. A circle graph is a diagram that uses parts of a circle to display data. It's also sometimes called a pie chart. On the board in front of me, I have an example of a pie chart that says usual transportation for high school students. Miguel surveyed 250 high school students about how they usually get to school. So he went around probably with a clipboard, had, looks like here, car, public transportation, school bus, walk, and other 5 options. He would have gone around and he would have said, "Hi, how do you usually get to school?" And if they said car, he'd check that one off. If they said public transportation, they would check that one off. And they were only given these options, though. It wasn't, oh, I take a scooter or my skateboard. Those would have been classified under other. So it was either car, public transportation, school bus, walk, or other. Those were the only options. The question says he displayed the data in this circle graph, and it asks, what does the light blue area represent? What you want to do is you want to look at the circle as a whole, and it would represent 100%. If it's a whole, it's 100. The light blue, it's color-coded, much like a bar graph, but instead of having a key or a legend, we can just see that this section is light blue, and it is talking about the headline or the title underneath it. So what does the light blue area represent? It represents the high school students who travel by school bus. This section represents the number of students who travel by school bus. Then it says, is it more or less than half the graph? So if we were to just look at it visually, we could see that it's not quite half. If we were to continue with the line, that would be half. But the other thing you can do is you can look at the bottom where it specifically tells us it's only 41%. So therefore, less than half the graph. Part B says, what conclusions might you make from this graph? So we're learning to read it overall, and we can see that although it's less than half, the majority of students who ride to school or get to school ride the school bus. We can see that the majority of students do get a ride to school. We can sort of clump this information together and say, well, you ride in a car, you ride public transportation, you ride a school bus. If we were to look at that section, it is a way larger section than those who walk. Walking is just 20%. If we were to look at ride, it would be 41% plus 9% gives us 50, plus car is 23%. That gives us 73% of students get a ride to school. So that can be one of our conclusions. We can say that other could mean biking, skateboarding, scootering, rollerblading. That's how they get to school. 20% walk. There are a lot of conclusions that we can draw from simply looking at this circle graph or pie chart. Quick refresher as we get into the heart of our lesson, our scatter plots. We need to really make sure that we are familiar with graphs. We remember that slope is the measure of the steepness of a line. Slope is calculated as rise over run and represented as m. So m equals rise over run. The y-axis runs vertically, the x-axis runs horizontally. Slope is going to be a huge component of finding correlation. It's going to be finding the relationship of data that were presented. So it's important to note that a positive slope means the line is going up and to the right. And that's like the growth that we saw on our other examples, where our line is going up and to the right. It's making a positive incline. Now it can be a straight line. We saw in our other ones the exponential growth as opposed to exponential decay that had a curve to it. Either way, it's positive, it's moving forward. For the sake of our lesson 8 scatter plot, we're looking at this straight line here. A negative slope means that our data points are going down and to the right. It's going down, it's moving negatively. To determine the slope of the line, we need the coordinates of 2 points on the line. That's how we can really tell what the slope is. Now, a line with slope m and y-intercept b can be represented by the equation y equals mx plus b. And we got into this when we did our linear model, and we looked at how we, I'm just trying, there we go, how we can tell if a model is linear or quadratic or exponential. So we're using that same formula here. Remember, a lot of our lessons are building on what we already know, so we built that foundation and now we're building on it with understanding scatter plots. Looking at our 1 and 2 variable data, in statistics, a variable is an attribute that can be measured. One variable data set gives measures of one attribute. 2 variable data sets gives measure of 2 attributes for each item in a sample. So 1 variable data, you can recognize these situations when you see tally charts, frequency tables, bar graphs that we talked about, histograms, pictograms, circle graphs, all of these we just finished looking at. These are one variable data, and they can be analyzed using mean, median, or mode, which we talked about. On the other hand, we have two variable data. You can recognize two variable situations when you see ordered pairs, scatter plots, and two column tables of value. So today's lesson, lesson 8 scatter plots, we're looking at two variable data. Now that you have the background, we are going to turn to page 21 of your IL book, where we jump into scatter plots specifically. It's important to note that a scatter plot is a graph that is simply a series of points. It's these plotted points. It's these pairs that we've been working on, and it's just a bunch of them. On the example that I have in the board in front of me, we have temperature along our bottom x-axis, and then we have sales rising up the y-axis. And we can see we have this positive slope. We can see it's moving up and to the right. So something is telling us that as the temperature gets warmer, the sales increase. So if we had to make a guess, we could say as the temperature gets higher, what do you sell more of? You sell more popsicles, more bathing suits, more flip-flops, more something that correlates with as the temperature rises, so do the sales. Now, scatter plots, we just talked about, represent two variable data as points. They may reveal a relationship between the two variables, much like the example we just talked about. As the temperature rises, so do the sales. In two variable situations, one variable may be dependent on another. That means its value changes according to the value of the independent variable. Such thing as, for example, the value of a car depends on its age. So we have one dependent variable and one independent. For scatter plots, typically we plot the independent variable on the horizontal axis. That's our x-axis. And the dependent variable, the one that depends on the independent, gets plotted on the vertical axis. This is important because when you're asked to graph a scatter plot, you will be marked on, did you label your axes completely and properly? As we alluded to with the example of as temperature increases, so do sales, we are actually drawing a conclusion. We are making a correlation, which is simply a relationship between the two variables. It's saying that as one happens, the other is happening. There's a correlation between. Graphing two variable data on a scatter plot may show a correlation between the variables. If you remember, data in a scatter plot can have a positive correlation, it could have a negative correlation, but there also might be no correlation at all. When we're talking correlation, a positive correlation describes a situation in which both variables increase together. On a scatter plot, the points are going up and to the right. So that is the example of as temperature increases, so do sales. Both variables are increasing together. Now, a negative correlation describes a situation in which one variable decreases as the other variable increases. So sometimes this is as age of a vehicle increases, the value of the vehicle decreases. That would be a negative correlation. On a scatter plot, it looks as if the points are going down and to the right. Let's try an example together to see if we can spot a correlation. Davis conducted an experiment comparing a person's leg length with how long it takes the person to walk 100 meters. He gathered these data showing leg length in centimeters and time taken in seconds. Graph the data. So here's a perfect example of you're going to have to make a scatter plot. We need to properly label our graph. If you need help remembering, in your study guide, there is a section on how to label a graph, parts of a graph. You must include a title. You must label the X and Y axis, and you need to focus on your scale proportion. Like we talked about with the beats per minute example, you can have that break in the line so that you can show what you're representing. We also want to focus on which data set variable goes on the X and which data set or variable goes on the Y axis. So we need to think of what is dependent and what is independent. Here we are talking about time taken in seconds and the leg length. So our independent would be our leg length, and that is going to go on our x-axis. So we're going to say, we're going to label leg length, and it says here leg length in centimeters. So you always represent the unit of measurement. That means our y-axis is the time taken, and it says it's going to be in seconds. So we represent that in seconds. We want to make our scale proportionate. If we look at our data sets, if we look at our plotted pairs, we have 80 and 66, 60, 83. So remember, the first one is our x, the second one is our y. So if we look at our x, our lowest appears to be 54. So we're going to do a break in our scale and have 50, and we can go up by, our largest x looks like it's 83. So I'm going to go up by 5. So I'm going to say 55, 60, 65, 70, 75, 80, 85. And I did that break to show. Now my seconds, the y, the time, it looks like my slowest time is 62 and my fastest time is 83. So again, I'm going to do that break, and I am going to say 60. And I think I can go 65, 70, 75, 80, 85. We'll go up by 5s again. So I've labeled my axes, I have scale, I forgot my title. So we're going to call this speed according to leg length. And you can call it whatever you want. It just needs to be accurate so that if somebody's looking at this, they can tell right away what they're going to be learning about. And then what you're going to do is you're going to graph the data. So we are going to plot our pairs. We have 80 and 66. So I go to 80 and up to 66, and I plot that pair. Then 60 and 83. 60 and 83. Then I have 63 and 75. Then I have 83 and 64. Next is 73 and 70. Then I have 73 and 74. 73 and 74. 64 and 62. 78 and 76. So remember, I'm always plotting my x first. 78 and 76 up on the y-axis. 54 on my x-axis and 81 on my y-axis. My last one is 78 on the x-axis and 76 on the y-axis. So you can see that I have sort of a cluster of data that are kind of together, except I have this one outlier, and we're going to talk about him later. But right now, for this, I have this one. Oops, I didn't mean to move him. I don't know where he came from. What was that one? 65, 64, and 62. So I need to move him there. Here's my laser pointer. So I have this one outlier that's kind of down here by himself, but the rest are kind of clumped together. And if I had to, you can see this shape coming through. The next part says, does the graph suggest a relationship between leg length and time taken to walk 100 meters? If so, describe the relationship. This is where we need to look at our slope. We're looking at this section, the largest clumping or group of data sets. Yeah, there's one guy over here. He's an outlier. We're going to talk about him later. But for the most part, I can say that I have this shape. And now I can see if I were to make this line, make this shape here, we can see that because they're fairly tightly close together and a shape is noticeable, that there is a relationship between leg length and time taken to walk 100 meters. The points go down and to the right. This suggests a negative correlation. That means that the time taken to walk 100 meters tends to decrease as leg length increases. So the longer one's legs are, the faster they can walk 100 meters. The longer one's legs are, the faster they walk or reach the 100 meters. So we can tell that by graphing the different tests that were run. This was their leg length on our x-axis. So in centimeters, we had a person with 80 centimeter long legs, 60 centimeter long legs, 63 centimeter long legs. And the person who had their legs were 80 centimeters, they only took 66 seconds to walk 100 meters. Whereas the person with 60 centimeter long legs took 83 seconds to walk 100 meters. So by graphing the information, we can use a scatter plot and gain a correlation out of it. So then it asks us to use the scatter plot to estimate the time it would take a person with leg length of 85 centimeters. I'm going to get a different color here. We're going to look at if they're based on our line here. If their legs were 85 centimeters, it would take them approximately, so therefore leg length of 85 centimeters would take approximately, I would say, 60 seconds. Leg length would take 60 seconds to walk 100 meters. Because we're just looking at that graph, that line, and we're going to get into what that line is. This is just getting us ready for the information. Davis conducted an experiment comparing a person's leg length, how long it takes the same person to walk 100 meters. He gathered these data showing leg length in centimeters, time taken in seconds. How might Davis make the results of his experiment more reliable? If Davis wants to know If this is an accurate representation, more data would make Davis's results more reliable. The more data, the better, always. The more information you can gather, the more accurate it'll be. He could recruit people with a wider range of leg lengths. Rather than getting everybody who's quite similar, he could have a wider range. So if we looked at our plotted points, we saw that they fell between the 54 to 83. If he wanted, he could have larger. He could have maybe from 30 centimeters to 90 centimeters. But the other part of that is you want to have other factors stay the same. So you want a wider range of leg length, but you want to keep other factors the same because age could affect the results, your gender, your body type. If those were vastly different, then you would get very different results. We're going to keep talking about this as we continue with the second part of Lesson 8 tomorrow. But that's all we've got for today. I hope you